Hello everyone, my name is Derek Manning, and in this video I will be walking you through the setup for a distributed machine learning cluster using Raspberry Pi 4s and also Apache Spark. The first step in this process is to gather all the different pieces of hardware that we're going to need for the cluster. For my setup, I've just sourced the majority of my hardware directly from Amazon. The minimum hardware that I'll be using in this walkthrough consists of 4 Raspberry Pi 4s using the 4GB of RAM version, 4 32GB micro SD cards, a customized Raspberry Pi cluster case, an 8-port gigabit Ethernet switch, 4 Ethernet cables, and a micro HDMI to HDMI adapter to use the Pis along with a monitor. Now, you will also need to buy a compatible power supply to go along with each Raspberry Pi, and you can do this either separately or also you could bundle it with the Raspberry Pi when you purchase it. I went with the latter option and ordered my Raspberry Pis as a part of a CanaKit starter kit, which throws in a power supply and heat sinks with the standard Pi 4 that you'll get otherwise. In addition to these components, you'll also need to have another computer for the initial setup with SD card reading capability to install the operating system for the Pis, and also an additional keyboard, mouse, and monitor will be needed to interact with the Pi cluster throughout the walkthrough. The next step will be to physically assemble the cluster. And once we have the cluster all put together, we'll go ahead and install the operating systems for each of the Raspberry Pis. Here's an example of what my assembled cluster looked like. Now with the cluster assembled, we can go ahead and install the operating systems. For this task, we'll be using a specialized Raspberry Pi operating system installer called Noobs, which stands for New Out-of-the-Box Software. Now I won't be covering the entire Noobs setup because there's already many great walkthroughs out there. So once you use Noobs to set up a baseline installation of Raspbian, we can go ahead and clone the SD cards so that we can have identical copies on each of the Raspberry Pis. For this task, we're going to use a program called Win32 Disk Imager. This will allow us to clone the baseline Raspberry Pi installation image to each of the other Raspberry Pi's SD cards. Now after this is done, upon loading into each of the different Raspberry Pis, we'll see an identical configuration. The next step is the networking configuration that's going to be connecting all the different Raspberry Pis together. We'll start things off by opening up a simple command prompt, and then navigating to our host configuration file. We will edit the file to give this Raspberry Pi a static IP address that'll serve as the first node in our cluster. Next, we will enable SSH through the Raspberry Pi's configuration menu. And once this is done, we'll navigate to this Raspberry Pi's host file. Within the file, we're going to modify it to add the IP addresses and host names of each of the nodes that we're going to have within our cluster. All that's left now is to modify this Pi's hostname file and to give it a single line, just being Pi1. We can now restart this Raspberry Pi, and upon reboot, we can open up a command line and we can see that now our hostname is properly displayed as Pi1. Next, we're going to modify our SSH configuration file. However, this file isn't generated until we first run SSH on the Pi. So to do this, we can just SSH into this Pi itself to generate the file. With the file generated, we can open it up and begin to set up our SSH aliases. Now, just like the host files, we're going to repeat this for each Pi that we're going to have in the cluster. The last step in this initial configuration is going to be generating SSH key pairs so that we don't need a password to be able to connect to different Pis in the cluster. To do this, we'll use the SSH keygen command, and this will create a pair of public and private keys that we can save between the Pis so that we won't need to use the password of each of the Pis when we're SSHing between them. With this, we're finished with our initial configuration of our base node, and now we basically just have to repeat these steps on the other Pis. Here we are on our second Raspberry Pi node, and now we're going to go through and replicate the steps we did on our first node. We'll start by opening up the host configuration file, and we'll assign it a static IP address to go along with its Ethernet interface. We'll go ahead and enable SSH on this Pi as well, and then we'll open up this Pi's host file. In this file, we'll be sure to change the default Raspberry Pi host name to Pi2, and then we'll also add in the IP addresses and host names of the other Pis within the cluster. After this, we'll move into the hostname file, and then we'll be sure to update that to Pi2 as well. Now, upon rebooting this Raspberry Pi, we'll rightfully see the Pi2 hostname listed in the command prompt. Now, all that's left to do manually on this Raspberry Pi is to perform the SSH keygen like we did on Pi1. And while we're at it, we'll also append this Pi's public key to the end of Pi1's authorized keys file. By doing this, we'll give Pi2 the ability to SSH into Pi1 without requiring a password. Now this process that we performed on Pi2, you can go ahead and repeat it on the rest of the Pis that you're going to be using in the cluster, and then we'll meet back on the original base node of Pi1. Alright, so here we are back on Pi1. Now I'm assuming that you have gone through the setup on the rest of the Pis in the cluster and have appended their public keys to Pi1's authorized key file. So we'll go ahead and also add Pi1's public key to this file, and then we're going to copy Pi1's authorized key files to the rest of the Pis within the cluster. And along with the authorized key files, we're also going to copy Pi1's SSH configuration file as well. With all these files copied between the Pis then, we're able to SSH between the Pis from one Pi to any other Pi in the cluster without requiring a password. Next, we're going to modify Pi1's bashrc file and develop some functions that are going to give us some ease of access on this cluster. The first function we're going to add is going to iterate through the Pis in the cluster and print their host names, and we'll just call this function other Pis. Before we run this command, we'll have to source our bashrc file again. Then when we run this function, you'll see it'll print the host names of the other Pis, excluding the current Pi that you're on. Now we'll add a couple more functions to the bashrc file. These next few functions are going to include a function to distribute commands throughout the cluster, a cluster reboot function, a cluster shutdown function, and then also a cluster command to copy files from a single node in the cluster to the rest of the nodes throughout the cluster. After sourcing our bashrc file again, we can test our cluster command function by using the date command, and we see it's working quite well. Next, we'll test our cluster copy function by copying Pi1's bashrc file to the other Pis in the cluster. And we'll test this by SSHing into Pi2 and then running the other Pis command to see if it works, and we see it does. The final step I'm going to be covering in this video is the installation of Hadoop and Spark to the cluster. We'll start this process off by using wget to download Hadoop. Then we're going to unpack the archive into the opt directory. Once this is done, we'll remove the original archive file and then change directories into opt. In opt, we're going to move the extracted Hadoop file into a directory just named Hadoop. Now we'll change the permissions of the Hadoop directory recursively, and then we're going to modify our bashrc file again, and we're going to add some export statements specific to Hadoop. We'll source our bashrc file again, and we'll test to make sure that our export statements are working by checking the version of Hadoop that we have installed. And we see we got the correct version. Now we're going to repeat this process nearly identically to download Apache Spark and to get that set up. The main difference in this process, aside from the different wget URL, will be the export statements that we're going to put in the bashrc, and then we're going to check to see if everything's all set up properly by trying to get the Spark version. And this works out as well. Next, we're going to set up some directories that we're going to need when it actually comes to running some Hadoop commands. Then we're going to go ahead and copy our bashrc file from Pi1 to the rest of the nodes in the cluster. And while we're at it, we're also going to use cluster command to create some directories across the cluster that are going to hold the Hadoop files at the different nodes. With these directories created, we're going to use rsync to copy the entire Hadoop configuration from Pi1 to the rest of the nodes in the cluster. Once this process completes, we can check to see if it works by using a cluster command to check the Hadoop versions at each of the nodes. However, if you run into some errors at this part, you may need to modify the bashrc file and move the export statements that we inserted earlier to the top of the file, and then you'll need to copy this throughout the cluster and source it again. Once you do this, the command should work, so we can go ahead and use a cluster command to get the Hadoop versions from each of the nodes, and we see that it works. And with that, this concludes this part of the walkthrough. In the next video, we're going to further configure Hadoop and Spark on the cluster, and we're going to run some basic jobs before looking into some more complex tasks. Thanks for watching.